let's talk about limiting reagent. Limiting reagent, as we can see from the name, limit. Limit means basically we have got a certain resources which is in limited amount, and if we run out of that particular resources, we won't be able to move forward with the process. Okay, so that means at certain point of time that particular resources will get over. So as we can see over here, it is in the chemical reactions, it is that particular substance, okay, which is totally consumed. Okay, so we won't be left with any of that particular component in that particular reactions. Let's say when we react nitrogen with hydrogen to produce ammonia, we'll take certain amount of nitrogen. Let's say we have taken 10 mole of nitrogen and we have taken 3 mole of hydrogen. So what can possibly happen is we may possibly run out of one particular reactant while forming the product, that is ammonia. Okay, so here in this case possibly we'll run out of hydrogen. So if we run out of hydrogen, so if we run out of hydrogen, then the hydrogen becomes the limiting reagent for us. Okay, hydrogen becomes the limiting reagent for us. That means it has got exhausted, okay, or it has been consumed totally. So we are left with nitrogen. So that means we have nitrogen in excess. Okay, so that means if one of them is a limiting reagent, the other one would be the excess reagent. Okay, so in very simple layman terms, limiting means the one which is in less amount or lesser amount, we can say. Okay, so the one which is in lesser amount is the limiting reagent for us, and the one which is in excess, or the one which will be left, would be the excess amount for us. So how do we know, or how do we calculate the one which is a limiting reagent, or how do we find the excess amount? To understand that, let's take some more other examples. So let's take a reaction to understand limiting reagent better. So let's say hydrogen reacts with oxygen to produce water. The first thing that we are going to always consider is balancing the reactions. Whenever any chemical reactions are involved in any calculations, this is the first thing that we are going to do. We're going to balance the reactions. So we have got one oxygen, so we'll make it two oxygen on the right side, so which would become equal to two oxygen on the left hand side. We have got four hydrogen on the left side, so we'll just multiply it by 2, so it becomes 4 hydrogen on both the sides. Now reading this equation, so 2 hydrogen molecule, that means 2 mole of hydrogen molecule, okay, will react with 1 mole of oxygen to produce 2 mole of hydrogen. Okay, that is the language of the reaction. Now in the exam, what is being provided to us is if we have 10 mole of hydrogen and let's say we have 6 mole of oxygen, which one will be the limiting reagent? We have to identify the limiting reagent. Okay, so in order to identify the limiting reagent, the first thing that we need to understand is we are going to compare the reactant. Okay, so how are we going to compare the reactant? We're going to say it like this: 2 mole of hydrogen. Okay, the first statement should be the one that we already know. Okay, we understand that 2 mole of hydrogen reacts with 1 mole of oxygen. Now that means as per the given condition of the problem, okay, the given amount, this is the given amount of hydrogen and oxygen. Okay, 2 mole, 1 mole, or 2 mole of water that we were talking about, that was the amount as per the balanced chemical equation. Okay, this is as per the given condition of the problem. Okay, So the first thing that we're going to write is from the equation. Okay, we'll write it from the equation. So from the equation, we have 2 mole of hydrogen that reacts with 1 mole of oxygen. So that means we are given 10 mole of hydrogen. So 10 mole of hydrogen would react with 10 times 1 divided by 2. Okay, so that is, we'll need 5 mole of oxygen. Okay, so we'll need for 10 mole of hydrogen, we'll need how much mole of oxygen? We'll need 5 mole of oxygen. But what is the given mole of oxygen that is being provided to us? It is 6 mole. So since it is 6 mole, so that means oxygen is in excess. Okay, we have more oxygen than we actually need for 10 mole of hydrogen. So if one is in excess, like I have told you earlier, if one is in excess, the other is the limiting reagent. So therefore, hydrogen is the limiting reagent for us. Okay, hydrogen is the limiting reagent for us. Now, what is the excess oxygen? Excess is we are given 6 mole of oxygen and we have used only 5 mole of oxygen. So that means we'll be having 1 mole of oxygen in excess. Okay. Now, if you want to understand this better in a simple layman term, then we can consider another very common example, okay, which we can use. I hope this will help you to understand better. So let's say we have a team. Okay, we're going to make a team with certain boys and girls. So let's say we have 10 boys and 12 girls in a class. Okay, so if we have 10 boys and 12 girls in a class, with this 10 boys and 12 girls, we're going to make certain teams. Okay, so we're going to, let's say for example, we're going to make one team. Okay, in one particular team, let's say the condition of the problem is there will be 3 boys and 4 girls in each team. Okay, so if we look into this one particular team that would have 3 boys and 4 girls, one thing is certain, that some of the students would be left out. So who are those students? Is it going to be the boys or is it going to be the girls? Okay, so the one that is going to be left out is an indicator that that particular part is in excess, and the one which is not going to be left out, okay, that would be the limiting reagent. So let's do the calculation. So what we say is we have got 3 boys. Like I told you earlier, to compare the by comparing the limiting reagent, we can easily find the by comparing the reactants, we can easily find the limiting reagent. So we have got 3 boys that plays with 4 girls in a team. So if we have 10 boys, we'll be needing how many girls? 4 into 10 divided by 3, so that is somewhere close to 12.3, a number that is a bit bigger, that is a bit larger than 12. So one thing is certain, if we have to involve all the 10 boys, the girls are going to be less. Okay, we have 12 girls and we need more than 12 girls. Okay, so from there we can say that the girls are the limiting reagent. Okay, just because some numbers are in larger form, it doesn't mean they are in excess. Okay, this is what we can experience from this problem. So the girls becomes a limiting reagent and the boys are going to be the excess. Okay, So if we would have looked at this questions other way around, let's say we had 10 boys and 12 girls. Okay, we had 10 boys and 12 girls. So if we have in one team there were 4 girls that was playing with 3 girls in a team. Okay, so that means if we have 12 girls, how many? This would be boys. Okay, 3 boys. So 12 girls would need how many boys? 3 into 12 divided by 4. So this is 4 3 times. We'll need how many boys? We'll need 9 boys. Okay. So what is the number of boys that is being provided to us? 10 boys. So one boy will be left out. So the boys are in excess. So excess boy or boys would be 10 minus 9. That would be equal to 1 boy. One boy will be left out because it is in excess. And all the girls would be playing. Okay, there would be no girls that would be left out, so the girls becomes the limiting reagent. Okay, I hope it is very clear with everyone why we are considering this particular example, because this is something that we can normally visualize. Okay, so related with the chemical reaction, sometimes it becomes a bit difficult for us, but once when we understand this logic, we can apply it anywhere we want. So what we can see is earlier we had taken the example of hydrogen and oxygen. Now we can take some more other examples like this: nitrogen and hydrogen forming water, sorry, ammonia. So if we balance it out, it will be like this. So now what we can see from the reaction is 1 mole of nitrogen reacts with 3 mole of hydrogen to produce 2 mole of ammonia as product. Okay. Now as per the given question will be given possibly like this. Will be given, let's say, 14 gram of nitrogen molecule that reacts with 6.02 into 10 to the power of, let's say, 24 molecules. 24 molecules of oxygen. Okay, so what we see is many molecules of hydrogen. So first thing that we need to do is we need to convert. If it is being provided in the question like this, we need to convert the gram into mole. Everything. I convert the gram into mole, the molecules into mole. Okay. Why do we need to convert everything into mole? The reason is the mole. When we are dealing it in terms of mole, the values will be relatively less. So as a result, it will be easier for us to do the calculations quickly. So let's say, for example, if we convert this into number of moles, it would be weight over molecular mass. So 14 is the weight of the substance that is being provided to us, and the molecular mass of nitrogen is 28. So that is half mole. Okay, so we have half mole of nitrogen, and on the other side, the number of moles of hydrogen can be estimated like this: 6.02 into 10 to the power of 24 over your Avogadro's number, that is 6.02 into 10 to the power of 23. So what we have is we have got 10 mole of hydrogen that is being provided to us, and half mole of nitrogen that is provided to us. So what they're asking us is, they're asking us to find the limiting reagent. Okay, so we have to find the limiting reagent. We have to find the molecule which is in excess, and let's say we are also going to find the amount of the product, that is ammonia, that would be formed. Okay, so first of all, let's try to find the limiting reagent. For finding the limiting reagent, we are going to compare the reactant. So the first thing that we're going to do is we're going to compare the reactant. So what we have is 1 mole of nitrogen. Okay, as per the reactions, what can we see? 1 mole of nitrogen reacts with 3 mole of hydrogen. So 1 mole of nitrogen reacts with 3 mole of hydrogen. So what we have is, we have half mole of nitrogen. So half mole of nitrogen will react with half into 3, that is 3 half mole of hydrogen, that is equal to 1.5 mole of hydrogen. Okay, so what we need is, we need 1.5 mole of hydrogen, but what is being provided to us? 10 mole of hydrogen. So hydrogen is in excess. So excess hydrogen would be 10 minus 1.5, that would be 8.5 mole of hydrogen, that is in excess. So if one molecule is in excess, or one reactant is in excess, the other reactant would be the limiting reagent for us. So that is, nitrogen is the limiting reagent for us. Okay, now we have to also find, when nitrogen and hydrogen reacts with each other, it forms ammonia. So we have to also find the amount of the ammonia that can be formed if we take this much amount of nitrogen and this much amount of hydrogen. So another very important point that we need to remember is, if we have to find the product, okay, if we have to find the product, then for the product, we should know that we have to look at the limiting reagent. The product would be formed as per the limiting reagent. Okay, this is a very important point. We should take note of this. Okay, the product should be formed as per the limiting reagent. Now, limiting reagent is nitrogen, so the amount of nitrogen that is being provided to us is half mole of nitrogen. Okay, this is the amount of nitrogen that is being provided to us. Okay, so according to this amount, okay, according to the half mole of nitrogen, we'll get our product. Okay, we'll get our product. So we have 1 mole of, as per the equation, we have 1 mole of nitrogen, that gives us 2 mole of ammonia. 1 mole of nitrogen, this is as per reaction. Okay, as per the reaction, we have 1 mole of nitrogen that can be used to produce 2 mole of ammonia. Now, as per the given condition of the problem, the amount of nitrogen that we have is half mole of nitrogen. So half mole of nitrogen would be half into 2, that is 1 mole of ammonia that could be formed as a product. Okay, in case if they want us to find the number of molecules of ammonia, then instead of 1 mole we can write the Avogadro number of molecules. So this many molecules of ammonia. And in case if the question is with respect to the volume, then we can write the volume like this: 22.4 liter of ammonia. So whatever that is relevant to the questions, if they are asking us to find the mole, then we can leave it here. If they are asking us to find the number of the molecules, we can put these values over here. In case if they want us to get the value of ammonia in terms of the volume, then we're going to put this value. Whichever is relevant according to the questions, we'll put the values. I hope it's clear with everyone.